Pre-production information technology equipment does not need to be underwriter's laboratory listed in advance. The purpose of underwriter's laboratory listing is to ensure that equipment is safe for use in a specific application. However, pre-production equipment is not intended for immediate use and is subject to further testing and modification before being released for general use. Testing pre-production equipment in a lab setting is common practice in the information technology and communications industry. This testing is done to firstly verify the basic functionality of the equipment, secondly identify any design flaws or performance issues, and thirdly determine if the equipment meets the manufacturer's specifications. While underwriter's laboratory listing is not required for pre-production testing, it is important to take appropriate safety precautions. Testing should be conducted in a designated lab area with proper ventilation and safety equipment. Ensure that the equipment is properly grounded and protected against electrical hazards. Use appropriate personal protective equipment during testing. Manufacturers should be aware of the intent and scope of the pre-production testing and should provide guidance on any specific safety concerns or handling instructions. Pre-production information technology and communications equipment can be safely tested in a lab setting without requiring prior underwriter's laboratory listing. However, it is important to follow appropriate safety precautions and work closely with the manufacturer to ensure the testing is conducted safely and efficiently. Proper grounding is essential for electrical safety in a laboratory setting, particularly when dealing with pre-production equipment. Grounding provides a low impedance path for fault current to flow back to the source, trapping the circuit breaker or fuse and preventing electrical shock hazards. The grounding system should comply with the National Electrical Code (NEC) requirements, specifically Article 250. This article outlines the requirements for grounding and bonding electrical systems to ensure electrical safety. Key aspects of grounding include the use of a grounding electrode system, which typically consists of a ground rod, ground plate, or metal underground water pipe. The grounding electrode system is connected to the equipment grounding conductor, which runs along with the circuit conductors to each piece of equipment. The equipment grounding conductor provides a path for fault current to flow back to the source in the event of a ground fault. Bonding is another critical aspect of electrical safety. Bonding involves connecting all metal parts of the electrical system together to create an equipotential plane. This ensures that all metal parts are at the same voltage potential, reducing the risk of electrical shock. Bonding is typically achieved by connecting metal conduit, metal enclosures, and other metal parts to the equipment grounding conductor. Regular inspection and testing of the grounding system are essential to ensure its effectiveness. Ground resistance testing should be performed periodically to verify that the grounding electrode system is providing a low impedance path to ground. Visual inspections should also be conducted to check for any damage or loose connections in the grounding system. Proper ventilation is critical for maintaining a safe and healthy laboratory environment, especially when testing electronic equipment that may emit harmful fumes or gases. Ventilation systems remove contaminants from the air, preventing them from accumulating to dangerous levels. There are two main types of ventilation systems: general ventilation and local exhaust ventilation. General ventilation provides a supply of fresh air to the entire laboratory, diluting contaminants and improving air quality. Local exhaust ventilation captures contaminants at their source, preventing them from spreading throughout the laboratory. Fume hoods are a common type of local exhaust ventilation used in laboratories. Fume hoods are enclosed workspaces with a fan that draws air away from the user and exhausts it outside the building. Fume hoods are used when working with hazardous chemicals or materials that may release harmful fumes or gases. The selection of appropriate personal protective equipment (PPE) is essential for protecting laboratory personnel from potential hazards. PPE includes items such as safety glasses, gloves, lab coats, and respirators. Safety glasses protect the eyes from impact hazards, chemical splashes, and ultraviolet radiation. The type of safety glasses needed will depend on the specific hazards present in the laboratory. Gloves protect the hands from chemical exposure, cuts, and abrasions. The type of gloves needed will depend on the chemicals being handled. Lab coats protect clothing and skin from chemical spills and splashes. Lab coats should be made of a material that is resistant to the chemicals being used. Respirators protect the respiratory system from airborne contaminants. The type of respirator needed will depend on the type and concentration of contaminants present in the air. Proper training on the use and maintenance of PPE is essential. Laboratory personnel should be trained on how to select, use, and care for PPE. PPE should be inspected regularly for damage and replaced as needed. Working closely with the manufacturer of the pre-production equipment is essential for ensuring safety and efficiency during testing. The manufacturer can provide valuable information about the equipment, including potential hazards, safety precautions, and handling instructions. Before beginning testing, it is important to review the manufacturer's documentation and consult with their technical experts. The manufacturer can provide guidance on the proper setup and operation of the equipment, as well as any specific safety concerns that need to be addressed. Communication with the manufacturer should continue throughout the testing process. If any unexpected problems or issues arise, the manufacturer can provide troubleshooting assistance and guidance. The manufacturer can also provide feedback on the performance of the equipment, which can be used to improve its design and functionality. The National Electrical Code (NEC) provides comprehensive guidelines for electrical safety in laboratories. Compliance with the NEC is essential for protecting laboratory personnel and equipment from electrical hazards. Article 110 of the NEC covers general requirements for electrical installations, including requirements for wiring methods, overcurrent protection, and grounding. Article 300 of the NEC covers wiring methods, including requirements for the type and size of conductors, conduit, and other wiring components. Article 400 of the NEC covers flexible cords and cables, including requirements for their use and installation. Article 500 of the NEC covers hazardous locations, including requirements for electrical equipment and wiring in areas where flammable gases, vapors, or dust may be present. Article 600 of the NEC covers electric signs and outline lighting, including requirements for their installation and maintenance. Article 700 of the NEC covers emergency systems, including requirements for emergency power sources and lighting. Article 800 of the NEC covers communications systems, including requirements for wiring and equipment for telephone, data, and other communication circuits. Understanding and adhering to the requirements of the NEC is crucial for ensuring electrical safety in the laboratory. Regular inspections and maintenance of electrical systems are essential for identifying and correcting any potential hazards. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overloads and short circuits. These devices are designed to interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Circuit breakers are resettable devices that can be tripped manually or automatically by an overcurrent. Fuses are one-time devices that melt and interrupt the circuit when an overcurrent occurs. The selection of the appropriate overcurrent protection device is critical for ensuring safety. The device must be sized to protect the circuit conductors and equipment from overloads and short circuits. Regular testing and maintenance of overcurrent protection devices are essential to ensure their effectiveness. Circuit breakers should be tested periodically to verify that they trip at the correct current level. Fuses should be inspected regularly for damage and replaced as needed. Electrical safety training is essential for all laboratory personnel who work with electrical equipment. Training should cover the hazards of electricity, safe work practices, and the proper use of electrical equipment. Laboratory personnel should be trained on how to identify and avoid electrical hazards, such as exposed wires, damaged equipment, and wet conditions. They should also be trained on how to use electrical equipment safely, including proper grounding, overcurrent protection, and personal protective equipment. Training should also cover emergency procedures, such as how to respond to electrical shocks and fires. Regular refresher training is essential to keep laboratory personnel up to date on the latest safety practices. Implementing a comprehensive electrical safety program is essential for protecting laboratory personnel and equipment from electrical hazards. The program should include written policies and procedures, regular inspections, and ongoing training. The program should also address specific hazards that are present in the laboratory, such as those associated with pre-production equipment. The electrical safety program should be reviewed and updated regularly to ensure its effectiveness. A designated lab area is an area that is set aside specifically for testing. The area needs to be properly equipped with the necessary equipment for testing as well as the appropriate safety equipment. Having a designated lab area ensures a contained location for safety protocols and efficient management. The area should have the appropriate warning signs visible. Proper ventilation should be in place at all times within the designated testing lab area. The appropriate safety equipment should also be available and ready for use at all times, as well as properly inspected and maintained. Ensuring that the equipment is properly grounded and protected against electrical hazards will allow for a safer and more efficient testing process. This will reduce the potential for electric shock and circuit overloads. Using appropriate personal protective equipment or PPE will reduce the potential for unwanted accidents during the testing phase. These measures are imperative for the safe and successful pre-production testing. Collaboration with the manufacturer is important. The manufacturer should be fully aware of the intent and scope of the testing to take place. They should also be able to provide guidance regarding any safety concerns or handling instructions related to the equipment being tested. This will allow for the safest and most efficient process.